All right, guys, this is our last little set of notes for our systems mini unit. Today we're going to talk about word problems. So you have your name there. This is the last little thing you need to put in your table of contents. We're going to do systems word problem. You can print the PDF if you want, or you're just going to handwrite it on a piece of paper. So you don't have to write down the essential question, but basically, what steps do you follow to solve a systems word problem? Make sure you title your paper. We're going to write down our short steps right now. It's not a whole bunch, but with word problems, the first thing you always want to do when you have your word problem is first you want to read the problem, right? And identify key numbers and information. Then you want to go ahead and define the variables. So with systems, you will always have two variables, and you want to define them so you know what they represent. The third thing is you're going to go ahead and set up, or you're going to write two equations using your two variables. You're going to solve them using substitution or elimination. I mean, technically you could do graphing as well. And then the last step would be to just make sure that since it's a word problem, you want to answer in words, so you want to answer in a sentence. So we're going to use these 5 little steps to do 3 examples. So you're probably going to have to pause the video to copy them down. Our first example says, a farmer has cows and chickens on his farm. He has exactly 42 animals with a total of 114 legs. How many of his animals are cows? So when I read through my problem, it says that a farmer has cows and chickens. So that's some important information. He has exactly 42 animals, and they have a total of 114 legs. All right. So one thing I should have had you add a little bit earlier was that a lot of times your equations, okay, not always, but a lot of times your equations are going to be set up kind of in this sort of form, okay? You're going to have like your total, number of whatever it is that you're talking about will be your first equation. And then they'll give you some sort of like feature about your problem, whatever the 2 variables are. You'll put those numbers in front of your y, and then that'll be equal to a second number. So that's kind of how we're going to set up this problem. It says that he has cows and chickens, and he has exactly 42 animals, and they have a total of 114 legs. How many of his animals are cows? Okay, so what we're going to do is first we're going to go ahead, we read our problem, we defined we kind of picked out some important information. Now we're going to define our variables. The question says how many of his animals are cows. So we know that cows is going to be one of our variables. Okay, so we have to decide what letter we want to use for cows. So we can use X, it doesn't really matter. And then we can have chickens, this is his other type of animals that he has. So I'm going to call that Y. It also says, it talks about legs. So you want to kind of pay attention that a cow, remember, has 4 legs. And that a chicken has 2 legs, right? So when I set up my equations, it was step 2 where we kind of defined our variables. When we set up our equations, we want to use the information that they gave us. So they told us that he has exactly 42 animals. So if I added the cows, which is X, plus my chickens, which is Y, I would have exactly 42 animals. Now I'm going to take into consideration their legs. Well, a cow has 4 legs. A chicken has 2 legs, and of all 42 animals, they have a total of 114 legs. So this little method of kind of setting up our equations, it's not every single problem is that way, but a lot of problems are going to be set up using that method where you add your 2 variables together to get, your total, and then whatever the key fact about them, maybe how much they cost or how many legs or how many per pack or whatever it might be, would go in front of your variables, and then, your equals. All right, so we can solve this using substitution or elimination. It doesn't matter which way. My preferred method is actually elimination, so we can go with that. Right now my y's, or my x's and my y's, they won't cancel, okay? So I can either multiply the x by 4 or -4 to get it to cancel, or I could multiply my y by -2 to get it to cancel. So either way would work. -2 is smaller, so I'm going to go ahead and multiply the top equation by -2. So -2x minus 2y equals -84. The bottom equation is just going to stay the same. 4x plus 2y equals positive 114. Why do I put a negative? So when I go ahead and add those equations together, my y's cancel, they eliminate, because I multiplied it by something that would make it eliminate. And then I have -2x plus 4x is 2x. -84 plus 14 is what? 30, right? Hopefully I'm subtracting right. Then I'm going to divide both sides by 2, and I get that x is equal to 15. Well, x represents the cows, so if we look at our word problem, it says how many of his animals are cows. So we don't have to figure out how many chickens there are. We would just take 42 total cows, or total animals minus the 15 cows, and get the chickens. But the question just said how many of its animals are cows. So to answer the question, we use a sentence, and we just say 15 of the farmer's animals are cows. And that's it. I was going to do this on one page, and then I'm going to flip my page over, and we're going to do the other 2 examples on a second piece of paper the back side, or second piece of paper for your digital notebook. So go ahead and pause here so you can write down your example number 2. It says Marty has only $1 bills and $5 bills in his wallet. If he has 18 bills totaling $62, how many of each type does he have? So we know that he has $1 bills and $5 bills. He has 18 bills totaling $62. How many of each type does he have? So we have to find both types. Okay, so first, I read through my problem. I kind of identified some important information, and now I'm going to write I'm going to define my variables. So when I define my variables, it's what he has. He has $1 bills. So maybe I call those X. He has $5 bills. This part's important because if you don't label them and then you create your equations and forget what's which, you might get messed up when you're answering. Remember that a $1 bill is worth $1 and that a $5 bill is worth $5. So when we set up our equations, it says he has 18 bills total. So he has X $1 bills, he has Y $5 bills. That means he has a total of 18. So he could have 1 of 1, 1 1, and 17 5s, or he could have 5 1s and 13 5s, or whatever, vice versa. Then we're going to take into consideration how much they cost, right? So he has a total of $62. Well, an X is worth $1. A Y is worth $5, and all 18 bills, if you add them together, is $62. So we can use substitution or elimination method. Either way is fine. It's set up pretty nicely for elimination because if I just subtract, it doesn't matter, I'm going to subtract the top one. So I'm going to make everything negative and subtract it. Then my x's already cancel out because they have the same coefficient. Negative y plus 5y is 4y. What's 62 minus 18? 44, hopefully. Yeah. Then I divide both sides by 4, and I get that y equals 40, no, not 44. Y equals 11. Well, what does y represent? Y is a $5 bill. And we know he has 18 bills total. So if we subtract 18 total minus his 11, that means that he has 7 $1 bills. So I want to answer in a sentence. So we would say something like, Marty has 7 $1 bills and 11 $5 bills. All right, last example. You guys can pause and write it down. It says during back to school shopping, you bought 2 boxes of pencils and 8 notebooks for $11. Your friend went on the same day to the same store and bought 3 boxes of pencils and 5 notebooks for $11.25. How much would 7 notebooks cost? Okay, so he went back to school shopping, bought 2 boxes of pencil and 8 notebooks for $11. That sentence is actually your mathematical statement that we're going to write. And then your friend goes, he bought 3 boxes of pencils and 5 notebooks for $11.25. We got to pay attention to the question. How much would 7 notebooks cost? So we don't want just 1 notebook, we want 7 notebooks. So we have boxes of pencils and we have notebooks. Instead of X and Y, this time I'm going to use P for pencils and N for notebooks. So I'm going to set up my equation for the first person. This one's going to be a little bit different than the other equations that we've set up because I'm going to set up how much I spent, right? So it's during back to school, you went shopping. So I went 2 boxes of pencils plus 8 notebooks, and it cost me $11. Then I'm going to set up my friend's equation. My friend bought 3 boxes of pencils plus 5 notebooks for $11.25. So I'm going to use these 2 equations to solve. So I could use substitution or elimination. Either method works. So I'm going to go ahead and solve them. Neither one can be like easily isolated. When I look at these 2 numbers, I can't multiply 2 to get 3. I can't multiply the smaller number 5 to get 8. So I'm going to have to multiply both equations. So I either want to multiply by 2 and 3 or 8 and 5. Since 2 and 3 are smaller, I'm going to multiply the top one by 3 and the bottom one by -2. Or I could have done the opposite. So I get 6p plus 24n equals 33. And then on the bottom, I get -6p minus 10n equals, what did that be, -2250. My p's cancel out the boxes of pencils. 24n minus 10n is 14n. And 33 minus 2250 is $10.50. I'm going to divide that by 14. Well, I do have some more room. I was afraid I wasn't going to have room on my paper. Divide that by 14, and I get that a notebook costs 0.75. So a notebook costs 75 cents. Well, the question says, how much would 7 notebooks cost? So I have to take 1 notebook, costs 75 cents, times 7 notebooks, I'm using my calculator around the side, would be $5.25. So to answer our question, we say 7 notebooks would cost $5.25. We answer in a complete sentence, okay? So again, the steps are right here. You read your problem, identify your key numbers information, define your variables. You can use something other than X and Y. I normally just use X and Y. Then you create your equations, you solve using substitution or elimination, and then you answer using a sentence. So this goes in on slide 10. This is what went in your table of contents, but this is like the notes part, and example number 1 goes on the left, and then example 2 and 3 goes on the right of slide 10, and then our little digital notebook is due on Friday. Okay, that's it. You're going to do some practice.